Assalamu alaikum everyone. This is Imri Khairul Hassan. My ID is 12108001. I am from session 2020-2021 of Department of Computer Science and Engineering of Kumilla University. So today I am going to discuss about XGBoost, one of the most powerful algorithm used in supervised learning. So let's start my presentation. Here is the outline of my presentation. The topics I am going to discuss you. So first of all, what is XGBoost? XGBoost stands for extreme gradient boosting. It's an optimized scalable machine learning algorithm which is most commonly used in supervised learning for like regression and classification. So it works by dividing the dataset into a fixed number of trees, and each tree tries to fix the error that is made by the previous trees. Then the key concept we need for understanding. So here boosting combines weak learners to create a strong learner. Gradient used to minimize the loss function. L1 and L2 penalties prevent overfitting. Parallelization, faster computation in multiple cores, handling missing values, and feature importance. So here is the mathematical formula of XGBoost. So we can define XGBoost as the objective function of L of I as summation of L of y of I plus y bar of I plus summation of f of k, summation of regularized term. So here the L of y I and y bar of I define the loss function, and the others provide their values. So then we just understand by the example. So here let's consider a data set that is for 5 students. So their study hours, and according to their study hours their GPA. So first of all, the trees calculate the average of them. So after averaging we got the initial 2.96 for all of them. So here the errors of the initial residuals. So for student 1, 2, 3, 4, 5 we find the errors. Then after that we goes to our iteration. So after calculating we just convert them into two trees, like for the study hours, where study hours is less than 4 hours and greater than 4 hours. So here we have the average residuals for all. So let's calculate by default learning rate. Mu is equal to 0.1. So let's calculate for the first. So new prediction equal to old prediction plus mu into f1 of x. So after calculating that, we found that for class 1 we got 2.89 and class 2 we got 3.0003. If we calculate those from the previous errors, then we will find that for the first it was 0.96 and minus 0.46. If we go after first tree, then we can see that the values has been reduced. It also reduced for those trees. So then after that we take those as our initial case and then calculate for those. The calculates goes until the number of trees we reached. So its stopping criteria is we have the fixed number of trees. Then validation error stops improving, then reach maximum learning depth. So if we can see that the model convergence, so at first the error was high. As long as we goes with trees, the error has been dramatically reduced. So we can also see that in our example. For the first, our error was 0.96, 0.46, 0.04, 0.54 and 0.84. Here the errors has been reduced in the first tree. So the error rate is reduced along with the trees. So its advantages are, so it gives a high prediction accuracy, it's handle missing values, it have feature importance, regularization, fast training, flexible and interpretable. So it has some disadvantage too, as it use a lot as it goes with tree. So there is a many parameters to optimize, so it increases time. So as that we calculate it with trees, it requires significant memory, and if we increase the data size, the trees number will be increased, so hence it will be slow, then there is the chance of overfitting, black box data preprocessing, and class imbalance. So what do we use? We use it in financial services, Kaggle competitions, healthcare, business analytics, marketing, real estate, and it is not ideal for text or natural language processing and time series. So important hyperparameters here. Then it's, if we compare it with other algorithms, we can see that it is better than all perspectives in random forest gradient boosting, linear regression, and neural networks. They provide good in some areas, like linear regression is very fast, but it has the low accuracy and its interpretability is high. And moreover, the neural networks accuracy is very high, but its speed is low and interpretability is low. So if we compare all of them, we can see that averagely XGBoost is better than all in all perspectives. So in conclusion, we can say that XGBoost is a power and versatile algorithm that combines multiple weak learns effectively, and it is excellent for tabular data, requires proper tuning for best result, and it is fastest for the regression or classification. So that is all. If you got any question according to my presentation, you can direct mail me, and thank you for listening.